Bismillah, hello friends. In this course, in the SAAT course, chemistry branch. In this lesson, we will focus in periodic table, our book page 10 to page 13. At the first question, the quantum number that indicates the energy of atomic orbits. We have four quantum number: principal quantum number, secondary quantum number, magnetic quantum number, spindle quantum number. The one that indicates energy is principal quantum number. Principal quantum number n takes the value from 1, 2, 3 to 7. So the quantum number that indicates the energy level or the energy of atomic orbital is principal quantum number. What about secondary quantum number? Secondary quantum number indicates the shape of the orbital. Magnetic quantum number indicate the magnetic properties of the orbital. Spin quantum number indicate the rotation of the orbital, the direction of rotation. Principal quantum number take the value 1, 2, 3, 4. It can't be negative and it can't be fraction. Sublevel or principal or secondary quantum number take the value S or letter S, B, T, F. Number of orbital: S has 1 orbital, B has 3 orbitals, D has 5 orbitals, F has 7 orbitals. The total number of orbitals related to the principal number: in principal number 1 first level has only 1 orbital, 1s. In the second principal quantum number second level has 4 orbitals, 1s and 3 on 1 in 2s and 3 in 2p. In the third level 3s and 3b. Here is 3 orbitals and here 1 orbital, and here in 2b 3 orbitals, and in 2s 1 orbital, and 1s 1 orbital. So the total is 9 orbitals. In the fourth level it has 16 orbitals as the same way: 1s, 2s, 2b, 3s, 3b, 4s, 3d. Which of the following numbers are correct for the principal quantum number? Only positive integers: 1, 2, 3 to 7. It can't be 0, it can't be negative, it can't be fraction. The principal quantum number for the sublevel 3d7. The principal quantum number are the number written in the front of the letter, so is 3. Another example: what is the principal quantum number in 2b1? 1 or 2 or b? It's 2. In 3s2, 3. The maximum number of electrons that occupies the first principal energy is 2. The first level 2, the second level 8, the third level 16, the fourth level 32. According to the rule 2n squared, n is the number of orbitals. Here 1, so 2 times 1 squared is 2. In the second, 2 times 2 squared is 8. In the third, 2 times 3 squared is 18. It's not 16, 18. In the fourth, 2 times 4 squared, 32. 2, 8, 18, 32. The rule is 2n squared. And the rule to number of orbitals, n squared, give the number of orbitals. For example, the first principal number has how many orbitals? 1 squared. The second has how many orbitals? 2 squared, 4. The third, 3 squared, 9. The fourth, 4 squared, 16, and so on. The maximum number of electrons that occupies the second level 2n squared, 2 times 2 squared is 8. The maximum number of electrons that occupy the third principal energy is 18. The third principal energy is 18 electron. 2n squared, 2 times 3 squared equals to 18. The figure represented sublevel. Which sublevel is spherical? Or another question, which of the following sublevel has a spherical shape? S is a spherical shape. B is dumbbell. F and D are dumbbell and complex. B are dumbbell in 3 axes, in X and Y and Z, but D and F are also dumbbell, but they are complex dumbbell. So the spherical one is S. S is spherical. The second principal energy level in an atomic container. Here the rule is N squared. The second, so 2 squared equals to 4. You're asked about the number of levels, number of sub-levels. The sub-levels 3px, 3py, 3pz, here 3, so the same energy. And B is the same shape, equal in energy and size, equal in energy, different in size, different in energy and size, different in energy, equal in size. They are equal in energy and size and also in shape. They have the same shape, dumbbell, and they have the same energy and size, but they are different in orientation in XYZ. Sublevel 2B and 2S has the same what? They are equal in energy, differ in size or differ in shape. These two principal number indicate energy, so same energy but differ in size and shape. 2S and 3S, same shape but different in energy. So the first number indicates energy, the second number indicates the shape or the size. How many orbitals are in B? B has 3 orbitals. How many electrons in B? B take 6 electrons. 3 times 2 give 6 electrons. Which of the following electrons are distributed according to Hond's rule? In Hond's rule, electrons are occupied the orbitals singly, then they pair. So B is true. D here pairs, and here empty one, and here they pairs in the middle. So the pairs start from right or left. So here C is not correct. The true answer is B. As Hond's rule, the electrons are enter as single, then pairs. For example, oxygen has 8 electrons. 1 is 2, 2 is 2, 2b4. If we draw b4, 3 orbitals, the first electron, the second, the third, and the fourth will start from here, according to Hond's rule. Which of the following sublevel is not in the atom? 3d, okay, 2b found, 5s, but there is 3f. F start from 4f, and D start from 3d, so no 2d. And B start from 2b, no 1b. So, which of the following sublevel is not in the atom? 3f, not found in the atom. F start from F. S start from 1. P start from 2. D from 3. And F from 4. Which of the following is the weakest sublevel or less energy? Which one come first? 4s come first. The order of the levels: 1s, 2s, 2p, 3s, 3b, 4s, 3d, 4b, then 5s, 4d, 5b, then 6s, 4f, f started from here, 5d, 5b, 7s, 5f, 6d, 7p. This is the all orbitals. SS, بس, دبس, فدب. It's a nice song to memorize the ordination of the sublevel electron configuration. Which of the following orbitals have this distribution here? 1, 2, 3, 4, 5. So it's D. How many electrons? 5 electrons plus 1, 6 electrons. So the answer is D6. That number is not necessary, but the number of electrons here is D, 6 electrons. Which of the following element has the electronic configuration 1s2, 2s2, 2b5? 5 plus 2, 7 plus 2, 9. Here 9 electrons. The down number here or the bottom number give the number of electrons. Here this electron. B take 5 electrons in halogens. Halogens are fluorine, chlorine, bromine, iodine. So we add the number of electrons give fluorine. What are the two last electronic configuration notation in the element silver Ag47? Knowing that krypton is 36. Ag47 and given krypton 36. Using noble gas notation, krypton is 36. After krypton we start 5s. Here 36 and 5s take 2 electron. Then 4d take 10 electrons, but here 2 plus 6 is 38. Here 47, so we have only 9 electrons. Here exception, if d take 9 electrons, we take 1 electron from s. So 5s is 1 and 4d is 10. We have two exceptions in periodic table. If d is 4, so take 1 from s, become 5. If d is 9, take 1 from s, become 10. The group of chromium, tungsten, and the group of copper, silver, gold. These two groups in transition metal are exception. So the answer is krypton 5s2 4d9. The answer is number C, krypton 5s1 4d9 as its exception. The element that is equivalent to the ion chlorine -1. We know that chlorine is 17. Here -1, so it gain 1 electron. We add 1 to 17, so 18 electron. And the opposite of the sign. If the sign is positive, we subtract, negative we add. Which one here has 18 electron? Here argon, magnesium or sodium. Argon is 18 electrons. So the answer here is argon. Argon 18. If sodium is positive 1, how many electrons? Sodium is 11 electron, positive 1, so we subtract 1 electron is 10 electrons like neon. Calcium is 20. If it's positive 2, so we subtract 2, it become like argon 18. Magnesium 12. Magnesium plus 2, we subtract 2 from 12 will be 10. The electronic configuration of the ion copper positive 2, knowing that argon is 18. Copper is 29, so argon 18, 4s2, 3d9. And we take 1 because here 9, so become 10. And 4s is 1. Now copper 2 lose 2 electron. From where it's lose 2 electron? Start from losing from s. So take 1 from s. And the other electron from d. Here 3d10 minus 1. So 3d9. So it's just argon 3d9. The answer will be argon 3d9. This answer. So the answer here number B. The answer is number B. Again, we make electron configuration for copper. Copper is exception. Argon 18. Then 4s1 3d10. Here copper positive 2 lose 2 electrons. We take 1 from 4s. Here only 1 electron. Lose this electron and subtract another 1 from 10 will be 9. The answer will be number B. Which of the following symbols represents the lowest dot structure for the atom lithium? Lithium has 3 electrons. So 1s2, 2s1. Dot structure take the valence electron, the electron in the outer level. Here only 1 electron. So lithium has only 1 electron, 1 dot. The answer is B. Valence electron. How we know valence electron? Make electron configuration, take the second level, or use the rule 2 8, 18. Here 3 electrons, so put here 2, and here the valence 1 is 1. Here the valence is 1 electron, so 1 dot according to Lewis structure. Which of the following symbols represented the Lewis dot structure for boron? We make our table. Here 2, here 8, here 5, so put 2. 5 minus 2 is 3, so the valence electron is 3. Which one here 3 dots? Number B. Or make electron configuration 1s2, 2s2, 2p1. The last principal level is 2. The number of electron here 2 plus 1 is 3. The number of electron in the outer shell is 3 electrons. So boron, and we make 3 dots of boron. The modern periodic table consists of 7 periods and 18 groups. 7 periods. Periods are horizontal rows. Groups are vertical columns. Which of the following is true about the electronic configuration? Argon 4s2, 3d10, 4b4. In period 3, no, it's in period 4. In 6 period, 7 period, 5 period. In number D, it's 4 period and 16 group. How we know the number of group? If the element ended with S, it will be 1, so group 1. S2 electron, group 2. So 4S can be group 1 or group 2. 4B, we see the electron configuration in B and add 12. Here ended with 4, we add 12 to 4, so in a group 16. This is the number of period, and B plus 12, 4 plus 12 is the number of the group. For example, oxygen 8. In which group? 1s2, 2s2, 2p4. We add 12, so in the group number 16. Nitrogen 7. In which group? 1s2, 2s2, 2 and 2, 4, so 2b3. We add 12, will be in group 15, and so on. An element that has an atomic number of 7 is located in which period? The first period only 1 and 2, so period 1 from 1 to 2. Period 2 from 3 to 10. Period 4 from 11 to 18. Period number 5 from 19 to 36. So here 7 is in period 2 because period 2 ended with neon. Neon is 10 electron and started with lithium 3 electron. So the element has 17 electron in which period? In the third period, period 3. Period 1, 2, 3. In the period 3, chlorine 17 electron from 11 and 18. And the one has 20 electron in the fourth period, and so on. Or you can make electron configuration. 1s2, 2s2, 2b2 plus 2, 4. Here 7, so 2b3. In which period? That's the number of period in the second period. The element phosphorus B15 in which period? 1s2, 2s2, 2p6, 3s2, 3b6. Here 2 plus 2 is 4 plus 6 is 10. 10 plus 2 is 12. So 3b only take 3. Which period? That number of the period in period 3. In which group? Here add 2, 3 at 12 in group number 15. In period 3, group 15. Or period 1 from 1 and 2. The second period from 3 to 10. The third period from 11 to 18. So it's in the third period. The element that has the electron configuration on S2 to S2 to P6 is in a group. Here the answer will be group 18 as its inert gas ended with 6, so inert gas. C, if ended P5 will be halogen. B6 will be inert gas. S1 will be alkali metal. S2 alkaline earth metal. Here ended with 6, we add 12, so in group number 18. In which period? In period number 2. Group 18, period 2. All elements found in group 1 in the periodic table are metals except hydrogen. In the group 1 started with hydrogen, lithium, sodium, potassium, francium, rubidium, cesium, or cesium, rubidium, francium. All this group contain only one electron in S sublevel. But hydrogen is a gas. The only gas in group 1 is hydrogen. The other are reactive metal, alkali metal. The element magnesium is in the second group, alkaline earth metal. Magnesium 12, if we make electron configuration, 1s2, 2s2, 2b6, 3s2, 3b2. Here 10 plus 2, 10 plus 2, it's 12, so we end in 3s2. 3s2 in group number 2, alkaline earth metal. Alkaline earth metal. What are alkali earth metal? We start with beryllium, magnesium, here 4, magnesium, 12, calcium, barium, strontium. This group alkaline earth metal. I submitted periodic table shaded with element. We should memorize it. Alkaline metal S1, alkaline earth S2, transition metal D from 1 to 10, halogens B5, inert gas B6. This is the common groups, we have to memorize it. Which of the following elements belong to the group of transition metal? Here gold, Au is transition metal. Mg and calcium and magnesium are alkaline earth metal. Sodium, alkali metal. Metals atom are chemically active because its ability to lose electron easily. Its ionization energy is very low, so it loses electron easily and formed cations or anions. It formed anions. Lose electron, so form anion. The elements in group 1 and 2 in the modern periodic table belong to which group? Transition metal, no. Inner transition metal, no. Inner transition metal, group 4F or table 4F and 5F, lanthanide and actinide. Representative metal, yes. Noble gas, no, it's B6. Except helium, helium is 1s2. Representative metal are 1 or S1 and S2 that has electron configuration in S1 or in S2 in P from 1 to 5. But P6 is noble gas. So any element take electron configuration in S1 or in S2 or in P from 1 to 5 is representative metals. Group 17 in the modern periodic table is called halogens. Halogens means salt forming. They form salts when dissolved or acting with metal, like chlorine, iodine, fluorine, bromine, and iodide. Metalloids in the periodic table are found only on from group 13 to group 17. Here the periodic table. Group 1, group 2, transition metal. Here B block. This column or this arrow diagonal are metalloid. Metalloid like As, Si. This between metal and non-metal. It's from group number 13 to group number 17. Which of the following elements is the most stable? Inert gases is the most stable. Helium, neon, argon, krypton, xenon, radon are most stable element, and they are all gases. Which of the following element has the shortest radius? The shortest radius to the left and down. Which one here left down? Rubidium. We found it here in the down. Rubidium and cesium are the shortest radius of all elements. Which one is largest? Largest one is here, fluorine and chlorine. The radius of the atom is equal to half the distance between two adjacent nuclei. Here, hydrogen H2, the radius of hydrogen is half the distance between two adjacent nuclei. When moving in a period from left to right, in the modern periodic table, the atomic radius increase, yes. The atomic radius decrease, no. The electronegativity decrease, no. It's increase. Ionization energy decrease, no. From left to right, radius increase, but other characteristic decrease, like electronegativity, electron affinity, ionization energy is decrease. From left to right, it's increase. This all three, electronegativity and ionization energy and electronegativity, increase from left to right, but the radius from left to right, it's decrease. The smallest element are found in the upright the periodic table. When moving in a periodic table from left to right in the modern periodic table, the atomic radius from up to down is increased, and from left to right it's decreased. So the answer here is the atomic radius is decreased, but the electronegativity is increased, the ionization energy increased. So the characteristic or properties, trend properties in periodic table, from left to right atomic radius decrease and all other properties increase. And in question 101, the energy required to remove the electron from a gas state, it's ionization energy. We have the first and second and third ionization energy. Third ionization energy is greater than the third. Third are greater than the second, and the second is greater than 2. So it's the third ionization energy is the greater, then the second, then the first ionization energy. In the modern periodic table, moving down a group, ionization energy decrease. So moving down, ionization energy, electron affinity, electron negativity decrease. Radius increase. So the only one is increased to moving down is radius, and the other is decrease. Like from moving from left to right, radius is decrease, and all other properties like electronegativity, ionization energy, electron affinity is increase. Electronegativity increase when moving to right and moving up. So the strongest electronegativity here is fluorine. If you order the element of the group in the periodic table like the following figure, then the atom fluorine F in the group has the largest atomic radius. No, it's the smallest. As going down, the atomic radius increase. The largest ionization energy, yes. The lowest electronegativity, the lowest carbon affinity, no, it's the highest electronegativity and the highest electron affinity, but smallest radius. Moving down a group in the periodic table, down, ionization energy increased, no. Atomic radius decreased, no. Electronegativity decreased, yes. Ionization energy doesn't change, no. The element with the greatest electronegativity, fluorine, or elements in group 17, the highest electronegativity, fluorine, then chlorine, and after come group number 16, oxygen. The element fluorine has the highest electronegativity. So here lowest, no. The lowest ionization energy, no. The largest, yes, the largest ionization energy. Fluorine and chlorine are largest ionization energy. And it's also the highest electronegativity. The elements that the lowest electronegativity from the following, lowest electronegativity is francium and cesium and rubidium. The number of electrons that can be held in the 4D, any D sublevel take 10 electron, F 14 electron, P take 6 electron, S only 2 electrons. The number of orbitals in the D sublevel take 10 electrons. Which of the following atomic number represented an element in the first group? Here 11. As we make electron configuration, 1s2, 2s2, 2p6, here 10 electrons, then 3s1. S ended with 1 electron, so it's in the first group alkali metal. Which of the following element has the smallest atomic radius? Knowing that the atomic number here, fluorine, is the smallest one, as it's in the up here in the group number 17, is the smallest radius and greatest electronegativity. Radius is inversely proportional with electronegativity. The second ionization energy is greater than the first ionization energy because the electron is more tightly bound to the nucleus. Because increase in positive charge density, the electron is further away from the nucleus. Decrease the positive charge density, electron has greater mass than the nucleus. Here, because shielding effect, electron is further away from the nucleus, so it's easy to remove electron, and ionization energy is the energy required to remove electron from the outer level. So it can be increase the positive charge, but if it's in the same period, increase the positive charge, increase the ionization energy. But here said, so the answer is most correct to be A, that here in the same period, second is more than the first, as the shielding effect here not required. Second is more than the first because increase the positive charge density. Which of the following compound has the highest ionization energy? The atomic number of iodine. The highest one is fluorine. And here we cancel potassium, so fluorine is the highest ionization energy. And the more lattic force or lattic energy also in Kf because highest ionization energy and the highest electronegativity. The ability of an atom to attract electrons in a chemical bond is electronegativity when bonding. According to Hund's rule, which is true according to Hund's rule? Here number C, as electron is singly here paired electron, but one is unpaired in S here, so not C. In A, paired electron opposite direction, so according to Hund, it's not required Hund here. Here S is 2 electron, B is 2 electron, and here one single electron in B, so the most correct one is B. The answer is B. For A, no need for Hund's rule. And here said in barium 5, so 1, 2, 3, 4, 5, just 5 electron. Here A, not 5 electron. Here one single electron and 2 pair electron, single in S, pair in B, so it's not correct. The answer is B. The electron configuration for silicon is 14. So neon 10, 3s2, 3b2. Answer is C. Neon 10, 3s2. After neon come 3s, 3s2, 3b2. In noble gas notation, noble gas configuration, helium after helium 2s. Neon 10 after neon 3s. Argon 18 after argon 4s. Helium, neon, argon, krypton after krypton 5s. The electronic configuration for the ion copper, here not copper, titanium, knowing that argon is 18, so argon 18, 4s2, 3d2, but here lose 2 electrons, so cancel 4s as lose electron from 4s. The answer is A. The same question was copper positive 2, was the answer D, but here titanium 4s2, 3d2, we lose electron from s, so 3d2. How many valence electrons are in nitrogen 7? So 2 5 valence electron is 5. Or make electron configuration 1s2, 2s2, 2b3. Here we add 2 plus 3 is 5. In which period? In period number 15. We add 12 to 3. Which of the following represented beryllium Be4? 1s2, 2s2. So only 2 electron in the last level. 2s2 is number A. Which of the following represented the number of unbound pairs in an ammonia molecule in H3, given that H is 1 and nitrogen is 7? Here ammonia, valence electron is 5 and bonded with 3 hydrogen. So only 1 pair is unbonded. If asked about the number of unbonded electron, 2 electron. Pairs, only 1 pair. 1 pair, 2 electrons. Here pair, so 1 pair. This is Lewis structure. Where is an element located if its electron configuration? Argon 4s2 in period 4 group 2. Period 4 group 2. The element which is similar to sodium in the same group, which one here in the same group? Lithium. Lithium, sodium, potassium, cesium, rubidium, francium in the same group. Similar properties are element in the same group, like F, fullerene, chlorine, bromine, iodine are similar. When comparing the size of magnesium atom with an atom, the size of magnesium is, here comparing with sodium or oxygen with oxygen. Or here is the question, oxygen. Which one is greater? Here magnesium and here oxygen. The one to the left is greater than the one to the right. In the periodic table, magnesium in a group number 2 and oxygen in group 16, so magnesium is greater than oxygen. Which of the following atoms has the greatest ionization energy? Which one to the left and up? Here all in group 1, so which one is up? Lithium is up. So lithium is the greatest ionization energy in group 1. Each electron occupies starting at the lowest energy level is called. Start from lowest energy level is Aufbau principle. The number of electrons in the same sublevel don't increase more than 2 if the electrons are around in an opposite direction is called this Pauli principle, in opposite direction. The similar single electrons in a rotation must occupy sublevel which has the same energy before this Hond's rule. So, Aufbau ascending rule. Pauli, one up and one down in opposite direction. Hond's singly if they are the same. If the principal energy level is 3, then the total number of orbitals n power 2, so 3 power 2 is 9. The elements in a group from 3 to 12 are transition element. A group 1 alkali, group 2 alkaline earth from 3 to 12 transition. A group number 17 is halogen, number 18 inert gas. From group 3, group 17 found metalloid. B block from group number 15, from 13 to group number 18 is B block. An atom is inert, an atom is chemically inert if it has high boiling point. No, it has lost ionization energy, electronegativity is high, it's stable or it is stable, has 8 valence electron. B occupied with 6 electron. Except helium, helium is 1s2. So the atom according to octet rule tend to be more stable. A group that consists of all group element, all gases, only group number 18, all gases, helium, neon, argon, krypton, xenon are inert gases. As we go down within the element in one group, the period table, the mass of atom decrease, the ionization energy increase, electron familiarity decrease, atomic size increase. Yes, atomic size increase. The energy required to extract or lose or give away an electron from an atom in the gaseous state, it's